Thanks, Adik. Yeah, so good afternoon, good evening to everyone. Let me start introducing myself. So I'm Prasanna. I'm working with ThoughtWorks as a lead consultant I've been working with ThoughtWorks for more than 12 years now. So I build enterprise softwares. For the last 3, 4 years, I've been typically working on large scale retail based systems. So this talk on micro frontends is actually sort of a repeat. I have done this in past, for the last 2 years, I've done it in like 3, 4 places. Uh, so this is more of a repeat, but of course, every time I myself learn from the questions, I myself go back and tweak things. Yeah, so this is more of my experience, and I thought if somebody has given me this information on day one of my micro frontend project, things would have been a lot smoother for me. So that was my thing. So my talk will be more structured around that. Of course, it will have a lot of flavors specific with what I have done. But yes, so I don't try to push my opinions too much, is what I think. Let's see. So this is what we'll be roughly covering about. Yeah, let's see when it actually comes into the background. So first is scaling applications, right? So this is something that is very close to my heart because I know my first part of the career, I was looking into more of learning a lot of stacks, a lot of languages, all those things. But then as I realized, I think I want to do this is what interests me a lot, like building an application and staying with it for like 3, 4 years, scaling it up with the users and all those things, right? To me, at least, scaling application immediately hits about scaling your application for the users. You have like maybe 10,000 users today, and in a year you want to have 1 million user. So how do you scale is what the typical thought process will be. So maybe you scale it horizontally, maybe you scale it vertically by adding more power to the service that you're having. Just add, like, horizontally means like when you can add more service to it, and design your systems around it in such a way that those things will not have impact or negative impact on the user base. At the same time, thinking about the cost, in a lot of times things like AWS and Azure, all those things, cloud-based services abstract a lot, which is good. At the same time, they hide a basic thing about the costing and all those things. So these are the main key things that will be there in my mind if I'm talking about scaling, right? However, the problem with scaling is totally different with respect to a front-end application, because this is whatever I spoke so far is purely a problem of a backend. Because where you have a server, where you have to serve so many people or so many requests and all those things. However, the scaling front-end app is not about the number of users. It's about how we can deliver front-end application with multiple teams as well as with the bigger teams, all those sort of things. As we see, the applications are becoming more and more front-end focused, all for good, because the personal computing hardwares are becoming more powerful. So you have a powerful browsers which can render powerful applications. So the obvious impact is, the front end is becoming a lot heavier than the backends. Even in the biggest of the enterprise systems, everybody will agree to this fact that a lot of things are happening more on the front end, and nowadays. Of course, still there are the worlds of IBM and SAP's still heavyweights on the back end, but still, there is always a attraction towards moving things towards the front end with a more jazzier, more attractive, more user-friendly applications. So in this world of where you have a very feature-heavy front end, now how do we want to scale the developments? Because imagine, like, if you pick up a project, you'll be likely to have like 60-70% of the work on the front end and like 20-30% of the work on the back end. And back end work is more of writing APIs, redundancy, and again, things like infrastructure services have made things a lot easier to spin up backend stuff. Uh, so you have to spend like 70% of the time on the front end. Now you need to have a bigger teams. You need to have a lot of parallelization. you need to scale your teams both ways, like increase the number of people as well as increase multiple teams. So this is a huge challenge because of the nature of the application, nature of the ecosystem that is around, which is JavaScript typically. So of course, things are maturing. If there are so many frameworks, in fact, that is also a downside. Like there are so many frameworks to pick from, so many frameworks to choose from, and the sustainability of these frameworks aren't so long. We don't know, maybe something that we picked up today might die down in a year. Oh, then what happens to my application after a year, sort of thing. Now, there are a lot of ifs and buts and things, with these sort of uncertainties, with this pace to grow, deliver faster on the front end, such things are to be introduced. And honestly, micro frontends isn't something new. It's maybe the wording is a bit new in the last 2-3 years. We are hearing it everywhere because the need has become pretty high. But this technology, the techniques are, whatever I'm going to talk here, are like way older. Like when I say like way older, it's around 5-10 years older technologies, right? But it's all about how we structure teams, how we run the delivery process of these projects. So those things are the challenges, yeah, about these micro frontends assets. Of course, it's a cool word to existing technique that we already have. Right. So before let me jump into, it's a very brief introduction. I hope everybody is kind of aware about what a monolith is. So monolith is an applications which is basically, it may not have a differentiation between a front end and a back end. Basically, the back end itself gives you an HTML, which simply gets rendered in the front end. Or maybe there is a bit of differentiation between a front end and a back end. But it's just one front end talking to one back end and back and forth, and they build things. And this is generally a monolith, and this is a perfect choice for anybody to start things, right? So if you are like a 2-developer, 3-developer project you're looking at, this is the perfect way because this is easy, this is lightweight, start off, you see a result immediately. This is perfect. So I'm not here to bash monolith, or it's not an ask to move the monoliths out. So that's the first thing. So the monoliths are applications which is wholesome, which serves entire purpose, and it might be or may not be differentiated between a front end and a back end, basically. Yeah, feel free to raise hand or something. I mean, if you think I'm just going too fast, or if you want to have some more clarifications on something, I'm happy to be interrupted. I don't mind stopping in between. So, and this is microservices. I think, okay, a very big buzzword in the last 3-4 years. Almost every backend, every enterprise is running towards this microservices. Again, the biggest ask for the enterprise is a scalability. Basically, they want to have a scaling based on the features. So like maybe their authentication system doesn't need to scale too much because they do it only once. Or maybe the streaming platform, streaming might need to scale a lot more. Or maybe they need to have more development teams churning out productive work. And also it's sort of easy to maintain systems if it's smaller. Once it reaches size, it's sort of hard. So trying to keep a check on the size of the application. So typically microservices has a lot of benefits, like from the module, like basically defining clearly which behavior should go where. You make sure the application doesn't grow huge. And of course, the independent deployments where you have you can deploy, for example, search feature, and you don't want to touch the rest of the application. You can be very sure that only search feature is going to be impacted, or change it, or maybe the scaling aspect also, right? You can scale it much better. Technology diversity. I think this is a huge reason for a lot of enterprises. For example, I work on retail. If you see the retails, they want a lot of databases, different types of databases to scale up. The product information should be in something like a Cassandra database where you have a lot of reads, where are very few writes. Maybe the writes happen only once in a day, but they have a lot of reads every day. Whereas they will need an order data to go in a proper SQL table sort of thing. So they need diversity. They can't have a single solution for their entire system end to end. And that is one of the huge reasons for a lot of enterprises to go towards some microservices. Said all these things, but there's a problem. I mean, this is good. This is really good, but microservices usually are like these. Like basically, all the blue bars you see here are the backends, and generally we build a lot of services. We are thinking about databases, different tech stack, and everything, and we scale the backend APIs. But typically, the front ends used to be a single front end for a lot of reasons, for a lot of good reasons. Um, so what the problem it brings is like you have independent deployments. For example, one of the APIs can deploy. Let's say search has added a new filter or something like that. They can do a deployment of their backend service, but they still need to wait for this front end to go live for the user to actually reap the benefits of it. Basically, it's not a release; it's just a deployment. So they can deploy and then they have to wait for this single team to help them finishing their front end, right? Now this causes bottlenecks because you have like 6 or 8 backend teams keep pushing every day and front end has to cope up. So that is a huge challenge, and this is exactly derived the way for something like this. Okay, we did it in backend, why can't we just do the same in the front end, right? It's exactly what is happening. So we did the same thing in the backend, and we are trying to do the same in the front end. And if you see, this is actually paving way for independent teams, very independent team that can run end to end, that can run from the state of planning to the state of release by themselves. They don't need to be dependent on anyone. Like each vertical column here is actually our team. So they can do planning, they can do design, they do development, test it, deploy it all end to end. They don't need to say, no, this, I need to wait for this team. I need to plan a release according to these teams and things. So that's the idea. So what are the biggest gains of micro frontends? As I said, it's independent teams. This is the foremost important thing. As you want to scale the application, you want to scale the development teams, you need to have very independent running teams. Independent teams that doesn't need to wait for others. It can perform independent releases. And we already saw this advantage of the microservices, a simpler code base. The same thing is also applicable for the front end. Basically, the front end will not be a huge code base. It can be a simple, smaller pieces of code bases. And the last is upgrades. I mean, again, front end is something very much volatile with respect to the packages and things. So you have to keep upgrading things. And if you have a huge application, you won't do the upgradation of packages or anything because you're simply worried, because you may not be aware about what will break, right? So if you have a smaller code basis, you tend to do much quicker, much reactive or proactive upgrades. Yeah, so that is useful for the application, that's useful for the team. But it doesn't come for free. I mean, of course, if it's for free, everybody would be doing it. And so we need to think about some of the problems that need solving before we take this, we adopt this micro-frontends. So one of the, at least this is all my opinions, right? Like one of the biggest thing when we started off with the project is, do we share things or not, right? So to me, I always feel the duplication of code is a very overrated problem. Actually, duplication is okay. I always feel that like it's okay to duplicate things because it helps you to go faster. Of course, there's always you should always, it can't go too much, otherwise it's like a problem, I agree. But it's simply overrated. Whenever we see a single duplication, we just try to, pull it out, make a common thing out of it, and then share. So that means it actually, so if you share more, basically you're introducing coupling more within the systems. So this is a very hard thing. It's not like there's no easy answer to say, you have to do this or not. But this is one of the constant debates that you will be having, especially when you have micro front ends, because you'll be talking about a lot of things on the front end. And you'll say, okay, do I need to just copy paste this piece of code from service A, or do I ask them to pull it out into a common library? Do I need to share, and all those things? So that's one of the common constant thing that we need to keep discussing about it. The other is about the loading performance. So you can easily do lot of mistakes with respect to micro frontends that can kill the performance of the front-end application. And yeah, of course, there are a lot of ways to mitigate it. So that's one of the problems that needs to be solved. It's not like impossible to solve, but it's just that you need to consider those things before you pick up micro frontends. And this is one of the key area that people are kind of restrained to do micro frontends. Is one of the problems is the design consistency, right? Okay, I see a 5 pixels margin on one page. In the next page, I see like 20 pixel margin. Keeping it consistent across pages is sort of hard if it's not in the same code base, if it's not coming from the same library, or if it's some sort of thing. So that's one of the hardest, biggest whys against micro frontends. This needs to be, people need to be aware about this, but there are ways to solve these problems.
Just very
So
quickly, Prasanna, on that last point with design consistency, in terms of sequencing, does it make more sense than to have a design system in place before you go down the route of building micro front ends?
Sure. I think I'll be covering this. I hope I will answer your question eventually. But if not, we'll definitely have this conversation at the end of it, Savik.
Thank you.
Is that okay? Yeah. Because that's exactly what I'm going to talk about, the key decisions, right? We talked about the pain points or the problems that needs to be solved. So, and then we'll just go through what are the decisions that we have to take. So this is exactly what I had in my mind. If somebody has told me all these steps on day one of my project, it would have been awesome. And I had to spend like 200, 300 days in this project. I mean, not alone, but yeah, 300 days of the project to come up to all these design solutions. Yeah. So one of the first decision is to compose the front ends into a single application. Right now, we discussed about it. Like we have a lot of applications like a service team A, team B. There are multiple. Imagine all these colored files are coming from a single team, like different teams. From an end user point of view, they really don't care, right? They don't care whether you use micro frontends or a microservice or whatever it is. For them, they need to have a good experience. If they don't like a experience, I think they're not going to come back to you. That's the thing, right? From an end user, they really don't care about the technology. So for them, it has to be a seamless application. It has to be made as a single application. So how do we do this? So this is one of the key decisions in a micro frontends project. So this has to be the first decision that we have to take with respect to how this has to be done. So in my experience, we can sort of do it in two ways. So I'll just give a small use case and then I'll run through with how we can do it. It's a very simple use case. Imagine you are like, imagine like an Apple website where you can configure a laptop, or you can just search for some accessories, or maybe search for the entire laptop itself. And the other feature is about ordering the laptop, right? Something as simple as this. And so I will introduce another service here that's called a frame. So basically here the configure is a service that helps you to configure a laptop, and search is a service that helps you to search for an accessory or for a laptop itself. Order is just going to help you with ordering. And frame is something what is going to be the key thing for this composition. So I call it as a frame because it's just a holder. It doesn't have any logic. You can put the frame anywhere. You can put it in the Apple website, or you can put it in the Amazon website. It should still behave the same. Like it doesn't have any logic of its own. All it has to do is it just holds things together, right? So that's the service. I call it as a frame. So I'll be using these references. That's why I want to introduce this upfront before I get into this. So there are two basic ways of composition, right? One is you can do it in the build time. The other is you can do it using the runtime. So the build time is very straightforward. A lot of package libraries do that. Imagine configure team, search team, order team. Everybody creates a JavaScript package, which can go into something like an NPM itself, right? Maybe you have your private NPM, but something very similar to NPM. And frame is the one that actually builds the application. Whenever there is a new package available, maybe the frame can be configured to just download, or it's like a dependency, right? It can just download the dependency, build itself, and then deploys itself. So it's a very simpler way of composition. So one of the advantages, it's a very sorted, because you're using a tool like npm or yarn or whatever it is. It's very good. It has already solved the problems of dependencies. It can give you a very optimized package. If like 3 services are using, say, a single library, it doesn't duplicate it. It knows how to manage the redundancies and all those things. So those sort of things are sorted out solutions, and it's a very standard practice. And again, still the independent cross-team development happens because the 3 teams are different. They're gonna give different pieces of. They're gonna develop at their own pace. The problem is, again, it's end of the day, the frame becomes a monolith. Just that it's developed by different teams, it still has the same problem of dependency. Like, what if there is a pipeline in the frame that breaks, so nobody can deploy, those sort of things. And because we started off with this technique, and one of our huge problem was non-atomic deployments. So what happens is, let's say if we are a team of configure, we will have our own backend as well as our front end. So our front end will be pushed to a package repository. Technically, that's our deployment, that's over. And our backend will be deployed to the actual server. Now, the problem is, it takes some time for the frame to pick up this package and then build itself and then deliver. So that until that time, you technically have to depend on your magic of backward compatibility with your backends, because your backend is already deployed. So this is a huge problem for an independent teams, because independent teams aren't very independent now, because they are sort of dependent on some of the teams, and they think they're done with the job, but they aren't, because just pushing their front end to a package repository is not good enough. They have to take it to the production. They have to take it to the end user. So, but the backend would have gone. So basically, there's a sync mismatch with respect to a backend and front end. So that we call it as a non-atomic deployments. So the obvious way we moved from a backend, the runtime, the build time composition to a runtime. So runtime composition is something where the browser actually, takes everything from different services, stitches them together. So ideally, something like a frame is the first JavaScript that will be downloaded, and frame will have an intelligence to download the rest of the services, and the rest of the services will, try to get integrated in the browser. Most of the micro frontends I've seen is actually following this pattern because of the disadvantages I mentioned before, and also this is very easy to implement. Honestly, it's just like it takes roughly 10 lines of code. You can just Google for it. Like, it just takes 10 lines of code to do this, and there are so many tools available to achieve this thing, right? So I just listed a few of them. We tried out Tyler from Zalando, and we tried System.js was the final thing that we went with. There are a lot of tools. I mean, but this problem is not about tools, right? This problem is not about solving it, its problem is about the practice, about the teams, and how it. So tools are, maybe the single step, like it's one step towards your end goal, but yeah. But so most of the teams I have seen so far have chosen runtime composition, and you can do either a server side or client side, depends on your use case, depends on if you don't have frequently changing pages, maybe server side is really good. If you have very super dynamic pages, maybe client side was the go-to with and things. But if you see most of the libraries that they usually talk about micro frontends, they talk about a runtime composition. Right. So runtime composition, as you can see, it has independent deployments, atomic deployments, everything is good. And something that we need to worry about is the network calls, amount of network calls that we make. Again, there are solutions. If you go for a server side, you don't need to worry about this. But if you're doing with the client side, then you have to think about these things. The second decision is about how your frontends are going to talk, right? So end of the day, though you are building different applications, they have to communicate. Otherwise, it can't be treated as a single application. Again, there are two options there. One is using a state management tool, like your entire application can be using a single state management tool, something like a Redux or a MobX, or maybe a simple client window object, something like that. And you can share. It's like a global variable, right? You have your global variable, you keep accessing the global variable, and every other service can access those global variables. Of course, it needs a lot of synchronization, a lot of conventions in place so that nobody steps on each other's toes. But that's one of the easiest way to achieve a communication across the things. You can think about even a simple window object sort of thing. The other technique that eventually we followed was about events, basically, since event-based programming is like super cool, and this is there in the browser from the last 20 years. It's a lot of people like jQuery uses this a lot. Basically, you can set events. The browser is capable of handling events, basically, and the events usually gets bubbled up to the top. So you can attach listeners to your window object, and then you can do this. This is how a lot of the teams I've seen actually uses micro-frontends. Like Spotify is one of the big examples. If you go, they use a lot of iframes. It's a micro-frontend application. They use a lot of iframes, and they use they have built a sophisticated messaging system around this. But on the bottom of it, it's actually merely window events. Nothing more than that. So third thing is about the design consistency. So this is exactly what a topic that like Sadiq was asking about. How do we go about it? This is my experience, how we went about it. Because on day one of the project, so typically the problem is, so we had requirements from all sides. We need to build a big product. We know there are so many things to be built. It's like an 80-20 rule, right? You have 80% of the rule can be built in 20% of the time. So there are so many things to develop. There is a lot of churn was happening. We couldn't start off with a proper design system, and I don't think it is possible, right? So what we did is, imagine you have three teams, right? That needs to start. All three teams should start at full speed. At least at the initial phase, you'll have a lot of things to be done, right? At the same time, it has to be consistent. So how do we achieve it? Is like we had a teams, and what we did is we took people out of it, and we created something called design guild. So this is just a logical team. This is just a virtual team sort of thing. Basically, they spend one day amongst themselves. They make sure the design system is coming along well, and they build something called Styleguide. So how it should look, how the theme should look like, how the component should look, how a button should look, how much should be the margins, how much should be the animation should look like, and things. So they decide, they build it, because all the authoritative designers and very interesting, like people, some developers are interested, so we build something called Styleguide. The Styleguide is actually, you can treat it as more of a guideline book, right? We didn't make it initially as something sort of a library, because we all wanted to move fast. Now, if you build some sort of library, common library at the day one, then we all need to wait for that common library to be, like, for example, if you change something from a blue button to green button or something, then we need to wait for the common library to update. And what if we are not ready for the new thing that is coming up in the common library, which will break us? So what we took a conscious decision is, we are okay to take some hit on the design consistency. Before, this is like an alpha launch, we said, okay, we want to just get it as much as possible. So we get feedback on the UX, basically how the flow looks like. The flow looks, do we need to tweak the flows and things? And the alpha users are, consciously made aware that, there will be some hiccups. Maybe in one place you'll see a bigger button, maybe in the next page you'll see a smaller button, but it's maybe, because most of the time what we do is we do copy paste from the style guide, like whatever the button looks like, whatever the color looks like, we do a copy paste. And the design guild did a great job in making sure all our components look very similar. They are not same, but they are very similar. And then eventually we started doing this, we changed this guideline book to be more of a library, right? We started doing it slowly, because at that time, we started doing this only after a beta launch, basically. The reason is, now we are having a kind of stable application. Everybody understands the pages, everybody understands the components that we are talking. And we started doing we see very obvious components started showing up on the design, on the style guide. So we started pulling them out into a library. The difference is a guideline, you can just overrule it anytime. but a library you can't. So basically, if something changes here, it will have an impact on the other side. And this, so we started building library after a year. Technically, at that time, I would say around or 60-70% of the product is built. It wasn't very shabby, but it had some hiccups here and there. But the component library reduced a lot of size on our front end because we removed duplicates. And we started doing this only when we had attained some maturity on our designs, on our flows and everything. Yeah, so hope that answers your question, Sadiq. I mean, this is what we did. I think this was very sensible approach to go with, because if we started off with the library, we would have stuck with too much
I
of
don't think
dependency.
there's two things. One is obviously you delay the start, but two, you don't know what you don't know, right? And you can't really build a very comprehensive library if you don't have a lot done already in some sense. So I don't think from a sequencing point of view, even beyond being pragmatic, it's probably not even truly possible to the extent that it needs to be at the early stages.
Yeah.
I do have a question on this, though, relative to the component library. That implies that all the teams are using a compatible technology, right? You don't want to have a team using, if you have a library that is, let's say, React components, and the other team, one team wants to use Vue.js or something like that, then you have some compatibility challenges with that. I'm not sure that you necessarily experienced that within your team, because it sounds like you picked technologies that were compatible, but could you speak to that problem?
Yes, exactly. So, so these problems are solved. I agree. In my team, we didn't have this problem because all of us are on the same front-end tech. But for example, let's say, let me take a very simple example of we had an autocomplete feature. All it has to do is export a React component out of it. We didn't bother about exporting some sort of Angular component or Angular compatibility things, but we can write, like, if you can abstract, end of the day it's JavaScript, right? So you can abstract it in such a way that you can emit two different or maybe something like what Material UI does, right? They give you React material versus an NGX material, those sort of things. But eventually they make sure they have a lot of common piece of CSS and all those things going in together. We can do some things, but we didn't do this. You're right. Like we had a very sort of homogeneous things. We had one a Vue.js component, but that didn't use this library eventually because that was with Jassier and that had a lot of unique components of its own. But yes, definitely that is one concern that we need to address. Like, and typically I don't, suggest micro-frontends for the sake of using different technology or frameworks, because it's a pain end of the day to have multiple things. It gives you some advantage. Maybe you don't want to bet too much on a single stack. You can just try spread your bets across the stacks. But eventually, I don't think that will be your first motivating reason for going towards micro-frontends. But yeah,
typically
so
this is an acquisition problem. Yeah, my problem has been
exactly.
in acquisitions, right? You acquire new technology, it doesn't fit. I don't feel like having to rewrite the entire front end to get it to fit. I found that in other situations, if you can find a like a library like material design or material UI or something like Kendo, where they have like it's the same controls in 4 different flavors, pick the one you want, and then you can get some consistency like that. But it's one of the problems with this. Yeah.
Agreed. Agreed. I mean, building a component library is no easy game. It doesn't matter how technology it is. Right. The last is about testing. This is a huge problem because we used to, in ThoughtWorks, we used to follow CD, basically our development. We try to deploy to production as it is. It's always like we don't do rollbacks. We always go forward. Our rollbacks are kind of, we revert the code, it goes in. So for us, continuous delivery was a key thing. So with continuous delivery means we need to have a lot of automation. Right? We have to trust test. We have to trust pipelines. We have to trust. Otherwise, we can't just commit code and then just sit back. So testing strategy was one of the key things. They had a lot of areas of test. This is a testing pyramid. I think there are a lot of articles about testing pyramid or Swiss cheese-based testing and things like that. So we were using testing pyramid-based approach. So the bottommost base is the unit test, which is kind of a very independent test that will be just sitting in your repository. It just mocks everything else. The medium layer, like the middle section, is the integration test usually. So here I want to talk about only one sort of test, which is consumer-driven contracts. And this is not the only sort of integration test that we had, but this was a very key thing for us to keep the micro frontends up and running. A quick highlight on the consumer-driven contracts is something like, let's say if service A and service B are talking to each other, if a service A is exposing a service which service B is using, which means service B is a consumer. So what they do is service B says, you have to run the test. That is, they give a set of tests to the service A. They need to run this in the pipeline before they commit or before they send it to production every single time. So that means, so service A can be very sure that they don't offend their consumer. Let's say if a service is being used by like 10 services, basically they will have 10 different set of tests that has to be run. Only if all of them are green, they can actually go and deploy. And it's a responsibility of the consumers to give a very solid test so that they can't complain later, oh, you deployed and my service broke. That can't be a conversation that we can have. So that's usually consumer-driven contracts. It's very common practice in the backend again. So we got it into the front end. So for us, Frame was the consumer of all the services. Basically, every service gives their JavaScript, and Frame is the one that loads them and uses them. So what Frame did is Frame has to issue a contract for all the services. A contract it's not a very complex thing. It's a simple JSON object. It looks something like this. Basically, it has to tell, hey, you need to expose a store name of this type. If you change your name, then your test will break. So which means Frame will not work. You have to expose so-and-so components. If you rename any of the components within your library, within your code base, then this will break. And so you can't deploy, and because the Frame will not work. Frame is expecting to have these named components, and Frame is expecting these things. Basically, if anything changes on this JSON structure of your service, I can't work with it. So that's the information from Frame to the rest of the services. So the rest of the services run this simple test as part of their pipelines. So they don't deploy if it doesn't pass. Again, you can do it in any ways. It's not like you have to do this, but this is one way that you have to think about it, because you have to, it's a lightweight test, honestly, because it doesn't take a lot of time to run. It is very easy to maintain. We need to put some sort of contracts in place across the libraries. And since JavaScript is very flexible, you can do a lot of contracts in JSON. The other sort of test that we had is functional test. This is a Selenium based one, a browser based testing. We used to test only the happy parts. We don't have we don't have a very extensive test suite there. It just has main flows that are, we call it as a smoke test. So it just indicates a very high level. It has to pass always, but it doesn't mean if it passes, we are perfect. So it's like we don't cover all the scenarios. So that's one sort of test. We weren't very happy. I mean, I don't think we solved this problem in the last 2 years also, because the functional test is sort of the common piece of thing, right? So we always had these questions: who should own this functional test? When we should go and change this, and who should be writing these functional tests? So we created a guild that very similar to the design guild. We had a testing guild which actually goes and does this. But yeah, I mean, it's always it became a bottleneck. So people has very less trust factor on this functional test, but it still exists because the product believes that it's pretty cool to have it, to see a browsers automatically showing off some things. But I don't think any developers will be very enough happy with this, because it's not complete. At the same time, it's painful, it's slow, and everything. But we still have them. So that's other sort of testing that we were discussing. Yeah, quick recap on what we discussed. So one is about, first is how do you want to compose? How do you want to communicate is the next. How do you make sure design is consistent? And the last is the testing strategy. The fourth is decisions that I felt we took quite long after we evolved these decisions. But it's one of the key things that we need to look into before we start a Micro-Frontends project. So one of the last thing, like this is, so when do you use Micro-Frontends, right? To me, Micro-Frontends is something not every team should be striving for. So if you really want, a very distributed team, if you want very independent releases, if you have these needs, you go for it, because you have to pay a big price with respect to consistency, with respect to performance. And I mean, it's not like bad performance or something, but you have to spend time in fixing the performance, fixing the design consistency and things, right? And yeah, of course, as you said, like if you want to collaborate, because you might carry a baggage of a legacy system, so you have a different framework. You don't want to use the framework, you want to use a different framework. You don't want to rewrite on day one. Maybe you just try to put it as a box, put it in a box, basically use a different framework. And the last is about, I always think the teams should have a bit of maturity if you're building micro-frontends, because it's very easy to be sidelined saying, this is not my problem. But end of the day, they should have a focus on the end users, because at least when we started, we had a lot of issues, and where we had to collectively come sit together and work. Luckily, we were part of the same organization, so we come under the same umbrella somewhere. But imagine if you have multiple organizations, multiple teams, something, it's going to be a bit of a chaotic situation at the start to resolve issues, to come in together and to say, because you're going to do this integration with the browser, which happens at the end user level. There are a lot of challenges, honestly, to start with. So I would say the teams should have a bit of maturity, but they should have exposed to do something like microservices, bare minimum, because microservices do have the same problems in the backend. So they should have some maturity on these things, and they should be able to take it to the next step. Yeah. So basically, if you're going to micro-frontends, you're going for a long run. You're not expecting something to be a quick win sort of thing. So if you got to be ready for it, it's not a bad thing, but it's just a word of caution. If you're coming up something for 2 weeks, 3 weeks thing, so the micro-frontends is not your thing to go with, sort of. Yeah, so that's all I had on this. I think I just rushed through the end, but yeah, I'm happy to take any questions. And yeah, if you even have more questions, I think there's just closing time or something. And then if you have more questions, just me or talk to Sadhik. I mean, I'll share the email address. Maybe you can pick me. Anything. Thank you.
Yeah, thank you. I mean, I can definitely go a little bit over if needed, but any questions, anyone that wants to clarify anything that Prasanna has brought up, please feel free to ask now, or as Prasanna said, you can also email him later. I can get you his email address.
I did have one question that's related to server-side rendering and the implication that might have. There's not a lot of some technologies can do that, but does that implies a challenge as relates to runtime combination, if you would.
Yeah, I mean, it certainly depends on our use case, right? And server side, I'm thinking a very simplest approach is going to be something like a Nginx or Nginx modules, right? Like basically, Nginx can just give a HTML with saying different JavaScript collectively together, putting it in a single thing. It can be as simple as that. Just bundling them into a single server-side package. It doesn't need to be a HTML, but it can be a single JavaScript that is dynamically generated in the Nginx side of things, or some sort of server side. I'm not here referring about a React SSR or an Angular SSR, because I know there are a lot of constraints with respect to their renderings itself. I'm talking in a bit higher level with respect to something like a Nginx caching or. I know there is a famous site that actually does purely Nginx modules based one. I just really forgot it. It's a bit higher level, not on the React SSR, those sort of things, because there you'll again have to stick with your limitations with respect to your frameworks and all those things. It's not going to be straightforward.
Thank you.
Okay, folks, I think we're at the end of time. And first off, just wanted to thank everybody for staying on. And just one quick thing I wanted to bring up. I know many of you have already sort of spoken about one of the things that we're working on with the Archimydes Code as a Service offering. I will be sharing an update to that. We've been working on some iterations of our main marketing site that's more encompassing. We're sort of taking people more through a product journey. as opposed to the approach we had previously. So I'll share the latest versions of that at some point early next week, and would love any feedback that you can provide on it. But I'll send an email on that at some point once it's up and running. But thank you everybody for jumping on, and look forward to our next conversation.
All right.